transmitted serially one by one. The number of levels जो सैंपल्स ਨੂੰ levels ਦੇ ਵਿੱਚ divide करना है depends upon the number of bits used to represent the sample value. जिन्नियां बिट्स ਦੇ ਨਾਲ सैंपल वैल्यू ਨੂੰ रिप्रजेंट करना है ਉਹਦੇ अकॉर्डिंगली levels होणगे. So the number of levels n is equal to 2 to power m. For example, जे सैंपल ਨੂੰ 3 बिट्स ਨਾਲ रिप्रजेंट करना है ਤਾਂ 2 to power 3 8 levels लिते जाएंगे. जे सैंपल ਨੂੰ 4 बिट्स ਨਾਲ रिप्रजेंट करना है ਤਾਂ 2 ਦੀ पावर 4 16 सैंपल्स लिते जाएंगे. PCM consists of 3 steps to digitize an analog signal. PCM ਦੇ ਵਿੱਚ 3 steps ਨੇ. First is sampling जो ਆਪਾਂ ਪਹਿਲਾਂ ਹੀ डिस्कस कर चुके हैं. Then quantization ਤੇ तीसरा step है binary encoding. Before we sample, we have to filter the signal to limit the maximum frequency of the signal. Filtering should ensure that we do not distort the signal, that is, remove the high frequency components that affect the signal shape. सैंपलिंग ਕਰਨ ਤੋਂ ਪਹਿਲਾਂ ਸਿਗਨਲ ਨੂੰ ਫਿਲਟਰ ਦੇ ਵਿੱਚੋਂ ਪਾਸ ਕੀਤਾ ਜਾਏਗਾ ਤਾਂ ਕਿ ਹਾਈ ਫ੍ਰੀਕੁਐਂਸੀ ਕੰਪੋਨੈਂਟਸ ਜਿਹੜੇ ਸਿਗਨਲ ਨੂੰ ਡਿਸਟੋਰਟ ਕਰਨਗੇ ਉਹਨਾਂ ਨੂੰ ਰਿਮੂਵ ਕੀਤਾ ਜਾਵੇ. ਸੋ ਹੇਅਰ ਇਜ਼ ਏ low pass filter, then sampler, then quantization, then digital encoding, binary encoding. This is a transmitter, then it is passed through a channel. In channel we have a regenerators at different distances. At receiver we have decoder which decode this analog this binary input, then reconstruction filter which reconstruct the original modulating signal from the pulses. Analog to digital converter employs 2 techniques. First is sampling. The process of generating pulses of 0 width and of amplitude equal to the instantaneous amplitude of the analog signal. The number of pulses per second is known as sampling rate fs. Quantization, the process of dividing maximum value of analog signal into fixed number of levels in order to convert PAM signal into binary code. Quantization is a process in which we convert a PAM signal we get from sampling into number of levels. The levels thus we obtain are known as quantization levels. This is a process of, this is a modulating signal. First of all, sampling. In sampling we get various pulses of different amplitudes and these pulses are divided into number of levels. Number of levels are depending upon the binary bits we have used. In this case we use 3 binary bits to represent a sample. So we have 2 to power 3 8 levels. So accordingly these sampled levels are converted into the binary numbers by the encoder. So first is sampling, then quantization, then there is coding, and these binary numbers are transmitted serially one by one. Here first of all there is a analog signal. It is applied to a sampling process, we get sampled signal. Then this is applied to quantizing process. These sampled signals are converted into different levels and these levels are according to the binary digits we have used, and these levels are then encoded and we get a binary output which is transmitted serially. What is the process quantization? By quantizing the PAM pulse, original signal is only approximated. Approximation means, for example, there is a sample between 3 and 4. There is a sample whose value lies between 3 and 4. We approximate this sample equal to 4. Quantization ਦੇ ਨਾਲ ਜਿਹੜੇ ਆਪਾਂ ਨੂੰ ਸੈਂਪਲਸ ਮਿਲਣਗੇ ਉਹਨਾਂ ਸੈਂਪਲਸ ਨੂੰ ਆਪਾਂ ਅਪਰੋਕਸੀਮੇਟ ਕਰਾਂਗੇ. ਫੋਰ ਐਗਜ਼ਾਮਪਲ ਜੇ ਕੋਈ ਸੈਂਪਲ 3 ਤੇ 4 ਦੇ ਵਿੱਚ ਹੈ ਉਹ ਸੈਂਪਲ ਨੂੰ 4 ਦੇ ਬਰਾਬਰ ਮੰਨਿਆ ਜਾਏਗਾ. The process of converting analog pulses to PCM is called quantizing. Since the original signal can have an infinite number of signal levels, so the quantization process will produce errors known as quantizing error or quantizing noise. ਜਿਹੜਾ ਸਿਗਨਲ ਆਪਾਂ ਨੂੰ ਕੁਆਂਟਾਈਜੇਸ਼ਨ ਤੋਂ ਬਾਅਦ ਮਿਲੇਗਾ ਉਹ ਸਿਗਨਲ ਓਰੀਜਨਲ ਸਿਗਨਲ ਨੂੰ ਮੈਚ ਨਹੀਂ ਕਰੇਗਾ, ਕਿਉਂਕਿ ਓਰੀਜਨਲ ਸਿਗਨਲ ਦੇ ਵਿੱਚ ਇਨਫਾਈਨਾਈਟ ਨੰਬਰ ਆਫ ਲੈਵਲਸ ਨੇ, ਵੇਅਰ ਐਜ਼ ਕੁਆਂਟਾਈਜ਼ਿੰਗ ਸਿਗਨਲ ਦੇ ਵਿੱਚ ਫਿਕਸ ਨੰਬਰ ਆਫ ਲੈਵਲਸ ਨੇ। ਉਸ ਕਰਕੇ ਜਿਹੜਾ ਗੈਪ ਮਿਲੇਗਾ, ਜਿਹੜਾ ਡਿਫਰੈਂਸ ਮਿਲੇਗਾ, that introduce a error that is known as a quantizing error or quantizing noise. There are two types of quantization, that is mid thread or that is mid rise. There are another process in quantization is coding and decoding. The process of converting an analog signal into PCM binary codes is called as coding, and its inverse which held at a receiver is known as decoding. Both procedures are accomplished in a codec. Codec means coder plus decoder. Levels ਨੂੰ ਬਾਈਨਰੀ ਕੋਡ ਦੇ ਵਿੱਚ ਚੇਂਜ ਕਰਨਾ is coding, ਜਦੋਂ ਕਿ ਉਹਨਾਂ ਨੂੰ ਰਿਸੀਵਰ ਤੇ ਵਾਪਸ ਲੈਵਲ ਦੇ ਵਿੱਚ ਕਨਵਰਟ ਕਰਨਾ, ਸਿਗਨਲ ਦੇ ਵਿੱਚ ਕਨਵਰਟ ਕਰਨਾ, that is known as decoding. There is a diagram, waveform shows the decoding quantization process. This is analog signal. It is represented by 5 samples. Each sample is a duration of interval of time Ts. This sample lies between 3 and 4. So it is taken as 4. This sample is 6. Then this is 6 again. This sample lies between 3 and 4. It is approximated as 4. This sample lies between 2 and 3, it is approximated as 3. So the quantization is a process of approximation. Samples ਨੂੰ levels ਦੇ ਵਿੱਚ convert ਕਰਕੇ ਉਹਨਾਂ levels ਨੂੰ approximate ਕਰਨਾ is a quantization. Again this shows a process of quantization. Samples ਨੇ ਉਹਨਾਂ ਨੂੰ quantize, ਉਹਨਾਂ ਨੂੰ sample ਜੋ ਇਸ ਦੇ ਵਿੱਚ ਦੇਖੋ ਸ਼ੋ ਕੀਤਾ ਗਿਆ ਹੈ, ਇਹ analog signal ਹੈ। जो ये स्टेप्स ने, these steps represents quantizing signals. जो ये gap है, gap between the analog signal and quantizing signal. So this dark line shows the analog signal, dotted line shows the PM signal, whereas these ऊपर जो शो किते हैं, these are known as quantizing signal. जो ये gap है ना दे विच, it represents quantization error. Again this is a process of quantization. वैल्यू जो भी सिग्नल की वैल्यू सी 5 to 7.5, इट रिप्रजेंट एज इसकी वैल्यू सी 5 to 6 के विच इनू 6 दिता जाएगा। सैकेंड सैंपल की वैल्यू सी 6 to 7 इनू की रिप्रजेंट 7 रिप्रजेंट किया जाएगा। हेयर शोज नैक्सट सैंपल की वैल्यू 6 to 7 इट इज़ आल्सो रिप्रजेंट बाय 7। दिस सैंपल्स लाइज बिटवीन 5 and 6, इट इज़ रिप्रजेंट बाय 6। तो हरेक सैंपल नूं उहदी वैल्यू के अकॉर्डिंगली अप्रोक्सीमेट करना है। नंबर ऑफ लैवल्स होंगे डिपेंडिंग अपॉन द बाइनरी बिट्स वी आर यूजिंग। जे आप 3 बाइनरी बिट्स यूज़ कर रहे हैं एक सैंपल नूं रिप्रजेंट करने लई तो 8 लैवल्स होंगे। जे आप 4 बिट्स यूज़ करें तो 16 लैवल्स होंगे। वैन ए सिग्नल इज क्वांटाइज्ड वी इंट्रोड्यूस्ड एन एरर दैट इज नोन एज ए क्वांटाइजेशन एरर। हेयर वी शोज ए 2 टाइप्स ऑफ एरर्स, दैट इज राउंड ऑफ एरर and overload error. This is overload. The signal increases rapidly whereas the pulse varies very smoothly. The difference between this signal and pulse is known as overload error. Here we show the quantization noise. The difference between original signal and pulses represents quantization noise. In PCM system, each signal, each sample is represented by n number of bits. So n number of binary digits are used to transmitted per sample. Hence number of bits are very high, that is signaling rate is very high, so bandwidth is very large, plus encoding and decoding and quantizing process in PCM is very complex. Second type of digital modulation is delta modulation. In delta modulation only one bit, that is either 1 or 0, is used to represent the sample. The bit is either 1 or 0, 1 represents positive, 0 1 represents negative. So little information is transmitted, so the sampling rate is very low as compared to PCM. In delta modulation, only the difference between pulses is transmitted. So current pulse is compared with the previous pulse. If current pulse is more than the previous pulse, it is 1. If the pulse is lower than the previous value, it is 0. So each sample is represented by one value, either 1 or 0. The scheme works well for small changes. If there are large change in amplitudes, this will introduce an error. So here we shows these are the pulses. It is compared with the signal. Whenever the signal is greater than pulse, it is 1. Here 1, 1, 1. Whenever pulse goes high as compared to signal, we get 0. So current value is compared with the previous value. If it is greater than previous value, then 1. If it is less than previous value, then it is 0. So each sample is having a one value, either 1 or 0. Here we shows comparator to compare current value and previous value, and from this comparator we get a staircase. These are the staircase pulses which are also generated from this staircase maker, and we compare these two signals and we get 1 or 0 as a output. Here the process of quantization. There are some distortions in delta modulation also. If the slope of analog signal is much higher than of approximated signal, if there is a more difference between analog signal and approximated signal over long duration, here as here shown, the slope is very high of the modulating signal as compared to approximated signal, then this difference is called as slope overload distortion. Second type of distortion is the difference between the quantized signal and original signal is known as a granular noise. This is similar to quantization noise as we discussed in the process PCM. जिस तरह PCM ਦੇ ਵਿੱਚ ਵੀ original signal ਤੇ approximated signal ਦੇ ਵਿੱਚ difference ਨੂੰ ਆਪਾਂ quantization noise ਆਖਿਆ ਸੀ, ਉਸ ਤਰ੍ਹਾਂ ਹੀ delta modulation ਦੇ ਵਿੱਚ ਵੀ original signal ਤੇ quantized signal ਦੇ ਵਿੱਚ ਜਿਹੜਾ difference ਹੈ, that is known as granular noise. ਤਾਂ delta modulation ਦੇ ਵਿੱਚ ਦੋ ਤਰ੍ਹਾਂ ਦੇ problems ਨੇ, ਇੱਕ ਹੈ slope overload, ਦੂਸਰੀ ਹੈ granular noise. Here we shows slope overload distortion, when slope of the signal is very high as compared to approximated signal. दूसरा है ਜਦੋਂ steps ਦੇ ਵਿੱਚ ਤੇ ਜੋ steps ਮਿਲ ਰਹੇ ਹਨ ਤੇ original signal ਦੇ ਵਿੱਚ ਜੋ difference ਹੈ ਇਹ ਵਾਲਾ, it represents granular noise. ਇਹ ਪ੍ਰੋਬਲਮ ਇੱਥੇ ਤਾਂ ਆਈ ਹੈ ਕਿਉਂਕਿ delta modulation ਦੇ ਵਿੱਚ ਜੋ steps ਨੇ ਉਹਨਾਂ ਦਾ ਜਿਹੜਾ size ਹੈ ਉਹ fix ਹੈ, that is equal to delta. ਤਾਂ ਇਸ ਨੂੰ ਖਤਮ ਕਰਨ ਵਾਸਤੇ ਨੈਕਸਟ ਟੈਕਨੀਕ ਹੈ ਆਪਣੀ adaptive delta modulation. A better performance can be achieved if the value of delta is not fixed. ਜੇ ਸਟੈਪ ਦਾ ਸਾਈਜ਼ ਫਿਕਸ ਨਹੀਂ ਹੋਏਗਾ ਤਾਂ ਬੈਟਰ ਪਰਫਾਰਮੈਂਸ ਅਚੀਵ ਕੀਤੀ ਜਾ ਸਕਦੀ ਹੈ. The value of delta changes according to the amplitude of the analog signal. ਜਿਸ ਤਰ੍ਹਾਂ ਕਿ ਡੈਲਟਾ ਮੋਡੂਲੇਸ਼ਨ ਦੇ ਵਿੱਚ ਜੋ ਸਟੈਪ ਸਾਈਜ਼ ਸੀ ਡੈਲਟਾ ਉਹ ਫਿਕਸ ਸੀਗਾ, ਅਡੈਪਟਿਵ ਡੈਲਟਾ ਮੋਡੂਲੇਸ਼ਨ ਦੇ ਵਿੱਚ ਸਟੈਪ ਸਾਈਜ਼ ਫਿਕਸ ਨਹੀਂ ਹੋਏਗਾ, ਉਹ ਮੋਡੂਲੇਟਿੰਗ ਸਿਗਨਲ ਦੇ ਅਕੋਰਡਿੰਗਲੀ ਚੇਂਜ ਹੋਏਗਾ. ਇਟ ਹੈਜ਼ ਵਾਈਡ ਡਾਇਨਮਿਕ ਰੇਂਜ due to variable step size. It also better utilization of bandwidth as compared to delta modulation. Here we get improvement in signal to noise ratio. Here we shows the steps, the width of the steps, size of steps vary according to the modulating signal. So the second problem, first problem, that is slope overload distortion, is not here. Conclusion: the main advantage of these pulse modulation schemes are better noise immunity and possible of use of repeaters, which makes communication more reliable and error free. Thank you.